So we're talking about scale drawings, which are application of ratios. And the idea of scale drawings is that the drawing with what it represents is in a fixed ratio. So it's an accurate representation of that thing. So, for example, a map. So that's the most common example of a scale drawing, are maps. Or you have blueprints or technical things about buildings. You have diagrams of equipment or machinery. We have various other things, Chris, that we use. And use scale drawing. Okay. And all sorts of science, you do it all the time, biology, physics, chemistry, you can draw atoms and molecules, all these types of things, it's all in scale. Now, it's either a reduction of something, of a particular ratio, or it's an enlargement. So, for example, if someone's drawing a picture of a virus, we have an idea of what viruses look like. That's obviously an enlargement, because viruses are microscopic and tiny. Whereas this map is obviously a reduction, because this island is not that big. The island is hundreds of kilometers across, and it's very large. So we draw the map as a reduction of the original, of the real thing. So the thing called the scale factor, which is an important term, the scale factor is what tells us how much you enlarge something by or reduce it by. Okay, so if it's reduced by 1/10, then the scale factor is 1/10. You multiply it by 1/10, you get the drawing is reduced 10 times, and you get the original size. Or you might enlarge it by 1,000 times. You might have a scale model of a racing car or something, which is 1 to 200. So if you enlarge all the dimensions of that model by 200, you get the original size. So that's what we're talking about. And types of scales, you can have scales in all sorts of different formats. You can have something like this, 1 centimeter to 15 meters, which tells you one type of unit, which are the same, they're both distances, but it tells you that 1 centimeter is equal to 15 meters. So you have to always convert up from 1 centimeter to 15 meters. Okay? Or you can have them in the form A to 1. So for example, 60 to 1, which means that 60 parts of the original of the drawing is equal to 1 part of the original. And this is a reduction scale. So if you see the first number, this number A to 1, that means that your drawing is actually smaller than the original. Right? You've reduced. If you have something like this, 1 to 2,000 in the form of 1 to B, this is an enlargement scale. Right? Where whatever it was is enlarged. And so, 1 of the original goes up to 2,000 of those in the number. Right? We're going to have a look at some examples to see what happens in specific cases. Now you can also have lines, what are these things called on a map? Geography. These sort of things here. Scale, key, legend, all these sort of words. Okay, you can also have these, which give you an indication of, on the original, I suppose this would have been 1 inch or 1 centimeter, is 15 kilometers, etc. So you can measure this scale with a ruler and then carry that across to the map itself and see what the distances are. Okay, on the map, and so which tells you what the real distances are. Okay, so you can have different types of scale. It's basically the point. So usually it's most convenient if we have 1 to something or something to 1, because that's easy to then modify for any distances. If you have something in the ratio with a 1 in it, then it's very straightforward to work out all sorts of different ones, because we know what one part of this ratio is. Alright? And then there's some examples. Express the following scales in the form A to 1 or 1 to B. So we've got to look at which is bigger. Align this first. So we've got to look at 1 is bigger and then decide whether it's going to be A to 1 or 1 to B. So out of 5 centimeters and 4 meters, which one's bigger? 5 centimeters or 4 meters? Which one's bigger? 4 meters. Okay, so 4 meters is bigger. So this will be in the form of 1 to b. Right? Now, what else do we notice about these two things in this ratio? What's the problem here? What do we have to do to the two things, Jamie? Yeah, that's right. We have to have the same units. So let's change it to centimeters. So if we go at 5 to, how many centimeters in 4 meters? Really? How many centimeters in 4 meters? Well, how many centimeters in 1 meter? 100. So 4 meters must have 400. Good. Okay, so it's 5 to 400. But I want it in the form of this. I want it in 1 to something. Alright, I want the left-hand side to just be 1. How do I go from 5 to 1? What do I need to do with this ratio? Divide it by 5. So divide both sides by 5. Alright. So I'm going to get 1, 2. What's going to be 400 divided by 5? 80. So this is telling us that 1 unit on the map or on the scale drawing is equal to 80 of those units in reality. Okay? So for example, if this was a diagram, 1 centimeter on the diagram, 1 centimeter, is equal to 80 centimeters. Okay? So it's scaling up. It's a reduction of the original. Alright? Now, we've got 15 meters to 10 millimeters. Which one is bigger? 15 meters is bigger than 10 millimeters. Alright? So if that's the case, we want this one to reduce to 1, and this one will be A. So it's going to be in the form A to 1. Alright? Whichever's smaller is the one that we change to 1, and the other one's going to be a different number. Alright? So we need to do something to this first as well. They're both in different units, so we have to change them to the same units. So Tom, what's 15 meters in millimeters? 15,000, yeah. So it's 15,000 to 10. Alright. Now, how do I go from 15,000 to 10 to something to 1? What do I have to do? I want to make this side just 1. How do I go from 10 to 1? Divide by 10. So I'm going to divide both sides by 10. So this divided by 10 is 1,500. So 1,500 to 1. Alright, so what this means is, on my scale drawing, a particular distance, the real thing is 1 over 1,500 of that. Okay, so my drawing is 1,500 times bigger than the real thing that it represents. Okay, so this could be a drawing of, I don't know, something very small, like a microscopic organism or something. And so it's 1,500 times bigger than the original. That's what that means. It's reducing from 1,500 down to 1. Whereas this one's enlarging from 1 to 8. Alright? Following how we do this. The units have to be the same, and then you either, whichever's bigger is the one that's going to be the number, and the smaller side becomes the 1. Okay? So it's either going to be 1 to something or something to 1. Just like in these cases. Alright? Let's have a look at the next one. The length of a new building on a set of plans is 300 millimeters. If the scale of the drawing is 1 to 40, what is the actual length of the building? Okay, so we've got a scale which is 1 to 40, and on the plans, 300 millimeters is the length. So the question is, according to the plans, what's the real length of that wall? Or that length? So what we need to do is 1 to 40. This part, or one part, represents the drawing. This represents the drawing. And so the 40 parts This represents reality. Okay? So what this is saying is, the real length of the building is 40 times greater than what it is on the drawing. Okay? So it's 40 times bigger. So instead of 1, I have 300 millimeters. So what do I have to do to 300 millimeters to find the real length of the building? Yeah, times it by 40. And you see that what we have to do is, if I have to times whatever distance on the diagram, I have to multiply it by 40 to get to the real length. And so what I need to do is 300 millimeters multiplied by 40. That is equal to 12,000. Now, what's 12,000 millimeters? Can I make that a more manageable unit? 1,200. What's 12,000 millimeters is how many meters? 12. Yeah? So that's millimeters. And so 12,000 millimeters is equal to 12 meters. And so that's the length of the actual building. So the scale tells me that 300 millimeters, I multiply that by 40 to get to the real size of the building. Any questions about what I've done here? Have a look at the next one. That should be an insect. An insect is drawn in the scale of 450 to 1. If the length of the drawing is 9 centimeters, what is the length of the insect in reality? Alright, so what this is that the drawing is bigger than the actual insect. So the drawing is much bigger than the insect. It's actually 450 times. So another way we can think about it is, the 9 centimeters corresponds to 450 parts. Alright? The 9 centimeters is the 450 parts. Okay? But the original is 1/450th of the size. What do I have to do to 9 centimeters to find out the real length? How do I go from 450 to 1? Divided by 450. So if I have to divide 450 by 450 to get to 1, what do I have to do to the 9 centimeters? So you think about it like this, 450 to 1 is equal to 9 centimeters to something. Right? We have to do something. Then we have to do this operation, something here, to work out what we need to do. To go from 450 to 9, and whatever that is, we can then work out what we have to do to the 1. Yes. Yeah, that's right. So you divide it by, sorry, what am I dividing by? 50? 450. Divide by, yeah, so divide by 50, I get to 9 centimeters. So I get to 9. So if I divide the 1 by 50, I get 1 divided by 50 is equal to 0.02. No, because to get from 450 to 9, I have to divide it. So whatever I do to the first one, I have to do the second one. Why would you times? What happens when you times 450 by 50?
When you times 50 by 9,
Yes.
and then you times.
Yeah, but so that works the other way. So times 9 by 50. Okay, so I can move either way, but this way is multiplication. This way is times 50. Alright, so either way. Same here. If I divide by 50, I have to do the same operation for both sides. Okay? So it's 0.02 centimeters, which is equal to 0.2 millimeters. Alright, so that's the way that we figure out for this. So the idea is, it's equivalent ratios, equivalent fractions. We're saying 450 to 1, the 9 centimeters corresponds to the 450. How do I get from 450 to 9? Well, I have to divide it by 50. So then I have to divide the 1 by 50, and I find the other part of the ratio. Alright, any questions? Do people want an on or off? Just leave it off. Okay? So the exercise I'd like you to do is question 304, exercise 304. I'll write that on the board in a sec.